हरि करना।
Now let's see one more example. Suppose a rare disease infects 1 out of every 1,000 people in a population. Okay, 1 out of every 1,000. Okay, that's fine. And suppose that there is a good but not perfect test for this disease. If a person has the disease, the test comes back with a positive 99% of the time. On the other hand, the test also produces some false positives. 2% of uninfected people are also test positive. Okay, that's what the false positive. So 2% of uninfected people are test positive because the positive which has come out is false. That's why we call it as a false positive. So 99% of the time they get the correct one, and then 2% of the infected people are also test positive, and someone just tested positive. What are his chances of having this disease? So we have our 1 divided by 1,000. That's our priori or prior probability. Now there is a evidence, but you are not sure about the probability of evidence because you have the 99% of the time we get correct, and you have the false positive also. Now how to calculate this? Let's see. Of course you have to use Bayes theorem for this. So what are the chances of having this disease? So it's let's see after the evidence. So let's define the parameters. A has the has the disease, and B means test positive. Okay, so now let's say probability of A is equals to this one, and probability of A complement is equals to 0.999. Then probability of B, given the probability of the test positive, given that it is a pupil, it's 0.99. Probability of B test positive, given that it is not, it's a complement of a complement, it is not which is under this 1,000. Okay, so the second part, the probability of false positive is 2%, 0.02. So now we have to calculate, we want to know probability of A given that B. Okay, probability of A given that the B, probability of uh, the one who is infected, uh, given that with an evidence of B, that is it test positive, the test positive from the test. So again, you got the prior probability and you got the evidence. Now you have to calculate the posterior probability. For that you have to take all the existing world probabilities and do that. So P of A multiplied by P of B given A divided by P of A, P of B multiplied by given A, and then you have to take the complement, P of A complement multiplied by P of B divided by A complement. So hence your 0.01 multiplied by 0.99 all divided by same plus 0.999 multiplied by 0.02, and it's 0.0472.